Mineralogy, just like plate tectonics, is something all geologists study. Minerals are the basic building block of all of our rocks. So all Earth's processes have to do with rocks and minerals, even our soils. And this image is a cave in Mexico with huge gypsum crystals. We'll talk about the formation of crystals today in this lecture. Minerals are very interesting. Lots of people collect and study minerals. There are 4,000 known minerals, and that number is growing. We learn about new biological processes that form minerals. There are 50 to 100 new minerals discovered annually, and again, they usually have some, these days, biological component to their origin. Mineral names can be kind of funny. They are named after different people. They can be named after their primary element that makes up the minerals. People use different languages to name minerals. Here's an example. Olivine is olive green, so it's named after the color of the mineral. Named after different places near us. In Boone, we have the mineral hiddenite that's named after the town Hiddenite. Mineralogy is a field of study in geology. We have mineralogists at Appalachian State. It began as a descriptive science, so describing how describing the different varieties of minerals. So Georgius Agricola, a physician, many early scientists were physicians. He described minerals in 1556. It wasn't until 1669 that the profession was really in place. So Nicholas Steno, even though he also was a physician, he became more of a mineralogist over time. He took the science a step further. Instead of describing just the look of the minerals, he was able to talk really about the geometry of the crystals and use that as kind of a classification scheme, this systematic description of minerals. So like the crystal up above, that's the amethyst crystal, and he could look at the angles, the faces of that crystal hit each other and start classifying minerals and looking at their symmetry. The study of minerals really ramped up in with the development of the microscope. So in the 1800s, started looking at minerals under the microscope and shaving them into thin pieces and reflecting light through them and starting to study their optical properties. In the early 1900s, it was realized that you could send an X-ray through a mineral, and it was going to scatter that X-ray, called a diffraction, in a diffraction pattern. And then, as the graph on the bottom shows, it's going to create a graph, and those graphs are always the same for a particular mineral. So that is used then to identify minerals. X-ray diffraction, use an X-ray diffractometer, and the one on the right here, that machine is an X-ray diffractometer, and you can identify minerals. On the left is an electron microscope, and electron microscopes allow you to look down at the atoms of a mineral on the surface of that mineral, and you can tell then the atomic structure of that mineral. And remember back to Steno, using the angles and looking at the atoms and how they fit together really became a part of studying minerals, so these high-tech instruments. Why do we study minerals? Why do we care? Well, they're, like I said in the beginning, the building blocks of the planet. They make up all our rocks, they make up all the sediments, all the dirt. Everything is made up of minerals. So understanding Earth processes, the chemistry of the Earth, really takes a solid understanding of mineralogy. We also use minerals in industry. It's the raw materials for manufacturing. Minerals are ores, right? So, or ores are minerals, and we need to understand the chemical relationship of one mineral and another, and maybe the bonds between those atoms to separate out what mineral we want to keep and what mineral we want to discard, so we can use that mineral in industry. Humans also really like shiny things, so we have gems. So gems are like diamonds. Diamonds, there's diamonds, diamonds. Those are sought after, and it takes a geologist to figure out where that might be. The image is at the bottom. Here's a picture of a bunch of cut gemstones. In the middle is malachite. It's a copper oxide. We can get malachite and separate the copper from the oxygen, and it is a source for copper. And then there on the left is asbestos. Those asbestos fibers have now been shown to be dangerous, get in your lungs and can cause lung cancer, but they're a really great industrial mineral because they're really stable, and you can take those fibers and make products that are not flammable out of them, like insulation and ceiling tiles and brake pads. But we know now that when it's in the air, it can be pretty dangerous.